Hi guys, welcome back to the last segment of our show today. Guys, I hope you've been having so much fun. So far, we've looked at a sequence, right, which is in two ways. It's either an arithmetic or a geometric, right? There is also the quadratic sequence, which we really did not look at because I know that one you are very clear with. And then we also went on to look at a series, which is also either a arithmetic or a geometric. Now, with the geometric series, we then have when it is a converging series and a diverging series. What does that mean? Remember, converging, it is more like coming together, right? And diverging is more like going out. But mathematically, when you say something is converging, we are saying that it is becoming smaller and smaller and smaller. Diverging means it is becoming bigger and bigger and bigger, right? So that's what we're just going to look at. And then we're going to look at what are the principles that make it to be converging and what is the principle that makes it to be diverging. But for now, let's just quickly look at what exactly do I mean. Because I know at times I say all of these things and you're wondering, what is this guy saying? But then let me show you what I'm talking about. Now, we have what we call a converging and diverging series, right? A geometric series, one, will converge. What does that mean? The sum will approach a specific value, right? So the N will approach a certain value, which I can just say, let me not use A, because then I will confuse you. Remember, A we said is the first term. So it approaches a value K, which is a specific value that we do know. So there is a limit, right? If the value of R is trapped between -1 and 1. So the value of R should be greater than -1 and should be less than 1. So if it's maybe 1/2, then it's okay. If it's like 0, then also it is okay, right? And then a geometric series will then not converge. The not converge will therefore mean what? It is diverging, right? Because converge and diverge are like synonyms of one another. This means that the sum will become very, very, very large, right? The sum will be very large. And what this means is it is a very big number that you are going to get. It is approaching infinity, right? And then if R does not lie between the -1 and 1, so if my R is like 2, then that series is actually diverging. If my R is like -3, that series is also diverging. When a series is converging, we can then find the sum to infinity. Why sum to infinity? Because it is approaching a specific value, right? So if R is greater than -1 and less than 1, then we say this is a converging geometric series. Then I can use the formula sum to infinity is equal to A over 1 minus R. So one thing that I want you to please note here is when I say infinity, I'm talking about a number of terms that is infinite. I do not know how many terms are there, like 2, 4, 8, and then 16, 32, with an ellipsis at the end, meaning that it is continuing indefinitely. I don't know what is the last term or where must I cut the number of terms. Then I will use this formula. But the question will specifically say to you, calculate the sum to infinity. So you don't need to then have to memorize certain things that will then tell you whether it's infinity or not. They will tell you specifically on the question. Let's look at some questions with this. So firstly, you need to consider the sequence, right? I have 2, 1, 1/2, and 1/4. Firstly, determine the common ratio. Why am I saying determine the common ratio? The common ratio is going to tell you whether you will be able to find the sum to infinity or not. If the common ratio is not between 1 and -1, then clearly I cannot find the sum to infinity. But if it is, then I can find the sum to infinity. So let's see what I'm talking about, right? So the common ratio, remember, will be 1 over 2. So R will be equals to 1 over 2, which is the 1 divided by the 2 there. Let me just label them T1, T2, T3, so that you don't think it's this 1 over 2. So this is the same as T2 over T1, right? Let's look at maybe the other one. If I say T3 divided by T2 will give me the same thing. That's 1 over 2 divided by 1, which is also what? 1 over 2. So you can see that it's actually the same value. So my R is actually just 1 over 2. I was just trying to show you that even with T3 and T2, it will still be the same value. Now, let's go back. What did we say? Only if the R value is between -1 and 1 can I then use the formula. So is it? Because I got 1 over 2, it does lie between the -1 and 1. Therefore, I can find the second question that I have here. So to find the sum to infinity, it will therefore be equal to A over 1 minus R. Remember, the A value is the 2, the R value is 1 over 2. Then I press my calculator. Firstly substitute, then go to your calculator. 2 over 1 minus 1 over 2. But really here I don't think you even need your calculator, but let me do it with mental maths, right? So this will be 2 over 1 minus 1 over 2 is 1 over 2. So how many halves are in 2? You know that there's going to be 4 of them. So that will be my answer. So you can see that it is approaching a specific value that we have there, and that's how you will then solve that. Also, this can be given in the form of a sigma notation, right? So remember the formula of the sum to the geometric sequence, which is Tn is equal to AR to the n minus 1, right? We can try and link this back to that so that it becomes easier. But you don't necessarily need to do that. Remember my steps that I gave you, that we spoke about, expand it. So it becomes 2 into 1 over 3 to the exponent of 3. Why 3? Because the first position is at 3. Plus 2 into 1 over 3 to the exponent of 4. Plus 2 multiplied by, so not 2 over, 2 into 1 over 3 to the exponent of 5. So just get 3 terms. You don't need to get all of them, right? So automatically, guys, you can already see that the 2 and the 2 will divide when you're trying to find what the R is, and then the 4 will minus that. So it means my R will actually just be 1 over 3. Does this qualify me to use the formula for sum to infinity? Yes. Why? Because it is between -1 and 1. And then my A value will be the value that I have here, which is 2 into 1 over 27. Remember, 3 cubed is the same as 27. And then I will go straight to my formula. Then let me remove that formula up there. Remember, that was just for me to try and show you where this comes from. Now, to then find the sum to infinity of this, I will say sum to infinity is equals to A over 1 minus R, excuse me, which is equals to the A value we just said is 2 into 1 over 27, all divided by 1 minus 1 over 3. So here, you don't need to go mental maths on this. You can just go straight to your calculator. So let me show you. So this, firstly, the fraction, 2, open the bracket, another fraction, 1 over 27, and you close your bracket there, divided by 1 minus another fraction, 1 over 3. Then you get your answer, right? Which will then give you 1 over 9. Okay, so this will actually be equals to 1 over 9. And that will be my final answer there. Now, just to summarize everything that we've done, guys, is make sure that you write out the terms of a series when given the series in sigma notation. I did give you those notes for you to please look at. Also, the sigma notation of a series when given the terms as a sum. So it was the two steps that I gave you in terms of threes, right? I gave you 3 steps and 3 steps for 2 parts of this. It's when you are given the sigma notation, they want you to find the sum, or you are given the terms and they want you to write it in sigma notation. Just also, an arithmetic series is formed when adding the terms of a sequence where the terms differ by a constant, right? The constant difference that we spoke about. And then a geometric series also is when then the sequence, the terms are differing with what we call the common ratio. Remember, between the consecutive terms, guys. Not just any terms. You can't take T1 and T100. No, it must be T1 and T2 or T2 and T3. Like that, they must just be consecutive to one another. Our roadmap of what we've looked at so far, it was a sequence, and then we said a sequence, there is 2 of them, the arithmetic, and then the other one is the geometric. With the series, there is also arithmetic and geometric. And geometric and arithmetic, both of them can be written as sigma notation, and then with the geometric, it is either converging or diverging. If it is converging, then you can find the sum to infinity of that. So guys, really this normally, number patterns, I know that it is normally like 2 or 3 questions in the question paper when you're writing your exam. I promise you, if you just master this, it means you've already answered 2 or 3 questions and you got them right. Maybe there will be just that one question that gives you a problem, but already you would have scored some marks. And also look at your algebra, and then you can then strategize after that. But from me, guys, remember, mathematics is food for the soul, and everything that we've done here, only if you take it up and practice it, I promise you, it will nourish every fiber in you. From me, the Maths Doctor, until I see you next time.